Hello, everybody. There are already a lot of people joining, so we are glad to have you here for our last demo day. And we'll give others 2 more minutes to join. So if you don't have a coffee yet, get yourself one. And yeah, if you don't mind, you can put in the chat where you're joining from. So the GitLab team is joining from all over the world. We have the colleague Mikhail, who will help with answering questions, joining from Australia. I'm located in Germany, in Bavaria. Your speaker for today, Victor, is joining from Hungary. So we would be curious to see where you're coming from. So feel free to put that in the chat. And yeah, we'll wait another 1 or 2 minutes before we start the official housekeeping stuff. Yeah, I see Oslo, Norway, Italy, England. Also Germany. Hello. Oh, yeah, that's cool. You're joining from all over the world. It's nice to see. France, Switzerland. That's super cool. Yeah, well, okay. While waiting, some housekeeping stuff. So if you have any questions during the webinar, please put them in the chat. So in the Q&A or F&A chat. As I said, we have Mikhail with us. He will answer questions alongside the webinar. After the webinar, you will receive a follow-up email with the slides and the recording. Also, this will include the recording and the slides of the past 2 demo days, as this is part 3 of a session. So it means if you've missed one of the first 2 sessions, you can still check out and watch on demand. Yeah, apart from that, ask whatever you want to ask. We also will have some room for Q&A at the end, but as I said, answering alongside. And we will have some polling questions, so also as information for you. So keep an eye on that. We try to keep it as interactive as possible for you also to have the chance to provide some feedback. And therewith, I'll hand over to Victor Notch, our speaker for today. He's product manager at GitLab. And yeah, he will talk you through the webinar for today.
Hello, everyone, and welcome to this webinar. Let me share my screen because it will come handy throughout the webinar. So as already said, my name is Victor Nudge, and I'm here to show you how to do GitOps with GitLab. We will focus on just one part of what GitOps can mean if you use GitLab, but I hope you will find it interesting. A few words about me. I'm product manager at GitLab, responsible for GitLab's Kubernetes integration and infrastructure as code capabilities. And together with me here is on the call Mikhail Mazurski from Australia, who originated from Russia, who is actually I would say the lead engineer behind these integrations. And if you have any questions, just drop them in the chat. He will try to answer them if I cannot give me the time during the demo. But hopefully we'll have a chat at the end in formal Q&A live as well, where we can answer some of the questions. If you have some interesting Kubernetes-oriented use cases that you think GitLab cannot serve you today, please reach me out on one of the contact possibilities here. Especially try to be active on Twitter, so feel free to reach out to me as well there. And I would love to have a call in this case with you so we can learn from your use cases, as I believe that that's the best way for us to build an amazing product together. So what's the agenda for today? Feel free to answer the question that came up as I'm going through the introduction part. First, we'll speak about GitOps just to have a common ground for a common understanding what we mean by today. And then there comes the demo, which will be the biggest part of this call, where I will show you how to use what we call the GitLab Kubernetes agent to do GitOps with GitLab. Okay, as the results come in, just a few ideas. I don't know if you see the results. So the majority of you are still evaluating Kubernetes, no production workloads yet, but there are quite some people, like the quarter of you, who has even production these days already. And quite a few of you are actually deploying applications that you develop into Kubernetes, which is great. These, I think we will be able to serve some interest for all of you. And there is some interesting monitoring as well. Great to see this. Okay, so let's get started. What is GitOps? First of all, for the common ground, I would argue that GitOps is actually just a minor step in what we could call the operations experience evolution. And why I say this is that how does this evolution look like? The first person on the left is kind of like me, 20 years ago, working for a startup as a full stack engineer. By that time, I knew a few sysadmin folks who were more specialized than me in specialized infrastructure. Followingly, in the early 2000s came the DevOps movement. But first, let's speak about the SRE approach. I consider the SRE approach as one implementation of DevOps. But to fully understand DevOps and fully embrace it, I think we have to understand what SRE is first. And to make it very short, Google basically arrived at the SRE after they threw over some developers into the ops team. And that's where the systematic thinking about architecting your infrastructure with automation in mind comes from. And this provided a huge boost towards infrastructure as code, for example. So for this, you should just drop some engineers, developers to your ops team. On the other hand, the whole idea of DevOps is when you throw over ops responsibilities to dev team. That's often called shift things to the left, but the very interesting difference between SRE and DevOps is that in DevOps, you speak about responsibilities, while for SRE, you move people, developers to the ops side. And if you do it DevOps well, then likely we'll have some ops people in the dev team. Otherwise, devs will be really frustrated and they might just ignore the ops part. Otherwise, you will have automation emerging there as well. The primary idea here is to shift the responsibilities left because you want to streamline your processes, increase velocity, and you want to keep stability and security at the same time. So in this evolution, we got to a point what we call today GitOps. And what does it add to this evolution? All in all, I would say that GitOps is just a minor step in this process of operations experience evolution, and it's primarily re-catch marketing phase. The reason why I say that is because the SRE approach is about changing business critical processes with engineers. It's hard and costly. DevOps is a culture change. It's super hard. On the other hand, GitOps is primarily technology driven. So it seems to be easy, but actually you might think that, okay, you would just start at GitOps, but actually we are speaking about an evolution here. So you cannot step over the previous steps. You cannot ignore them. The SRE stage adds automation and this metrics-driven mindset to the whole experience. The value of GitOps without automation and metrics is questionable. DevOps culture change turns your developers to be the owners of the applications, even in production. Again, having GitOps is nice, but like if nobody owns those applications, then it doesn't have much value. So I would argue that you have to think of this as an evolution. And if this is an evolution, then the real question is what comes next and where are you right now? So you can go to next steps. And in both cases, you want to look at it as an evolution. So this is my approach to GitOps. I don't want to go into a huge amount of detail around GitOps. There is a GitOps working group at CNCF where the principles of GitOps were accepted a few months ago. There is still no definition, but the principles at least are agreed upon. I try to summarize the current state of art in terms of the evolution as we know it today. But actually we can try to break this down even more, by which I would say that GitOps at its core is to have some codified infrastructure that's automated, fast feedback loops. If you look at this, this is DevOps applied to your infrastructure. Okay, so this was all the introduction part. And let's see how we can do GitOps with GitLab. the driving principles would be to be totally automated. Everything is stored in Git. We recommend using Terraform for infrastructure provisioning, as GitLab has some amazing Terraform integrations. We will not deal with Terraform in this demo, but we have a poll for you for future demos, and as I speak, you can answer that if it's shown. So you can set up your cluster with connection, both for pull or push-based deployments, whichever you favor. Often, again, it's an evolution. You might prefer to have push-based deployments for your development clusters, for example, and pull-based deployments in production, or you just want to move and have a nice migration path with the features that I will present you. That's a possibility as well. Then you want to share single cluster connection with multiple projects, groups, provide integrated environments and analytics. Again, something that I won't speak about in this demo. And all of this workflow, you can drive it through merge request that allows for approvals and code changes to be checked by others as well. And of course, security shouldn't be left out either. So we'll have a poll about this later, which one you might be interested. And now let's turn to the demo. What will you do today? First, for this demo, you have to have a Kubernetes cluster at hand. And you have to be able to access it from your CLI. I will use K3D, so the cluster will run on my computer, but it can be anywhere in AWS, GKE, wherever you want. And what we will do, we will install the agent. I will show you how to do that a few ways. I will use the advanced method in the end, but I will show you the quick start way as well. And then we will have both pull and push-based deployments. In the meantime, I will describe what they are, and a few other features of GitLab will be presented as well. So what is this agent that I'm speaking about and that I mentioned a few times? You can connect a cluster to GitLab using the GitLab Kubernetes agent, and basically it is a component called agent K that runs within the cluster, and we will have to install it into the cluster, and it will reach out to GitLab, authenticate itself, and we set up a bidirectional streaming channel between itself, that is your cluster, and GitLab. This enables all kinds of amazing features, like the agent K can ask GitLab if there are any changes in the Git repository where your cluster is described, and can apply those changes to your cluster, or GitLab can notify the agent, I have some new changes for you, so please update the cluster. Or we can actually even apply container network security policies. And then those policies there's a breach, then we can just raise an alert within GitLab to have an integrated experience, and you can stay within GitLab for all these features. So that's why having this agent is a really, really strong feature for us that we try to base most of our integrations upon. What are pull and push-based deployments? Before we get to it, if you are not familiar with it, both are just about how you will modify your cluster, how you will access your Kubernetes API that actually modifies your cluster. In the pull-based deployment setup, what happens is something runs within the cluster, like agent K, as I just showed you, and it retrieves the manifests from a repository outside of your cluster and applies them. So the whole application happens within the cluster. As a result, this, in our case, agent K can follow along all the events that are fired throughout deployment. Those can be reported, and it's a more integrated experience. On the other hand, the push-based deployments are when, for example, you are in GitLab CICD, where you have a job that goes out to a cluster and says kubectl apply or Helm apply or anything else, and pushes the changes down to your cluster to be applied in the cluster. In this case, you have to have a logic in that outside your cluster component that checks whether the changes were applied successfully. So these are basically two different approaches. There are consequences in scalability and many other aspects, but let's keep it at this level for now. Okay, so let's go to the demo now. I prepared a few things for it, like I have a GitOps demo group. It's a public group. You will be able to see the project that we create here as nothing will be shared that shouldn't be shared. And let's start with creating a new project. First, I will start with a blank project, and this will be my, let's call it Kubernetes agent, with the plural because you can have multiple agents as well, even though we only use one in this occasion. README doesn't matter much, so why not? Okay, so this is a totally empty project, as you can see. Let's clone it, as I prefer to work here. Oh. And let's open VS Code to, okay, here we go. It just has at this point a single README file, as you can see, and I will create a file under .gitlab/agent/demo agent/config.yaml will be the file itself. And actually, I will leave it empty for the very first iteration. Added agent configuration. And let's push it to GitLab. So the changes have arrived. You can see them here. And the next step is to go to the infrastructure menu and Kubernetes clusters, to the GitLab agent managed clusters, and let's integrate it with an agent. Here you can see our demo agent that was added. If you want a quick start approach, I recommend just to go through this setup. I don't want to follow along. There would be one more step, and then we'll receive a token. Actually, I can do that. Yeah, let's do that. So let's have the demo agent. I hit next, and here, please don't misuse this token because I'm going to use this one in this demo, and I will remove it after the demo.
Victor?
What? Yes?
Sorry to jump in. We have someone asking in the chat if you can increase the font size. It's hard to read.
Oh, of course, of course.
Yeah, didn't want to interrupt you, but
thank you.
I had to.
Yeah, definitely. Let's increase the font size here. And okay, once we will have something, I will do it here as well. Here we go. It seems to be okay. Let me know if I need to increase it more. But so right now, what we did, we just created a new project in GitLab, cloned it, added a config YAML, pushed this empty file back to GitLab, and now we are registering the agent. This is where we are. In the agent registration flow, the first step was to select the agent that we created. And now it provides us a token that we can copy. We will do that. Or if you want a quick start approach, you can copy this Docker command, run it in your local computer, and it will just install the agent and everything. I will follow the advanced installation guide in this demo because that enables more flexibility and will come handy for later steps of the demo. But if you just want to get started quickly, feel free to use this Docker command. So let's go with the token here. And the advanced installation guide is actually described. You can get to this point from our documentation. We'll use KPT to grab, let's do everything within VS Code, why not? So we'll use KPT to grab the package. KPT is a tool by Google that has many nifty features, and what we are going to use, we use it mostly to, it enables getting a part of a Git repository, basically. It can be at a version tag as you see it now. And later on, it enables as well to update that checked out, that clone of the repository by keeping your changes and trying to merge with upstream at the same time. So that's why we use KPT, and that's why I recommend using that. So we just check out basically this package from a Git repository at a given tagged version into the packages/GitLab agent directory. Fail to clone Git repo. Oh, no, it makes no sense. Okay, let's try without, there might be no such tag that I tried. Oh, I just realized that actually, yeah, I removed this. I prefer to have an organization when the package is under package repository, and now I added it without that. So I will just move it under packages, but it doesn't matter much. So KPT package GitLab agent. Okay, I do not push these changes back to the repository yet because I have a secret to be added somewhere around here. But first, let's see our docs, what else it provides, because this is actually a set of Kubernetes customized overlays that you can see here. So we can do something like shown here. Customize packages GitLab agent. And you can set all these variables. The agent version right now is a stable version. Let's set that to the version that we will want to use. Cus address is the GitLab address. That's perfect. Cus is the cluster side component of this agent workflow. So you always have to have the Kubernetes agent server running somewhere. This server is usually set up by the GitLab operators within your company. Or if you use gitlab.com, then it's managed by the GitLab SRE team. And in that case, the address is cast.gitlab.com, and we will connect to it through WebSocket. There are a few other things. It might be easier to read if I get this closed. There are a few other things like namespace. You can add the name prefix as well, and you can decide whether Prometheus scraping should be enabled or disabled. It will be enabled by now. So if you don't know how to use these things in the docs, we have a few more ideas here, like config set. I will use that to set the agent version. The first one is the packages /GitLab agent, and the version is version 14.4.1. The versions available can be found in this repository where documentation exists. If you look at the available tags, actually, there is no .1 version, so that might have been the issue as well when I tried to get the package. So it will be 14.4.0 version. There are weird errors going on this day. Oh, I forgot to specify the key that I want to set, which is agent version. What the heck's going on here? This is very interesting, as the key item file is there. Did I mistype something? Yes, it's not packages, but package. Okay, so now the customized side of the setting is ready. And we need one more thing. We have to put the token that we receive into this base secrets agent token file. Of course, you could do the echo as well, but it's more human to just add this way. And so I go back here, I copy the token and add it into this file, not that file, but okay, this will be a bug report that I cannot use the copy functionality there. So the setup is actually done. I mean, the configuration part, and now I can just run customize build and apply these changes. If you prefer to have a look at the output, customize package slash cluster. I think it works this way as well. So if you just prefer to look, then remove the pipe part into kubectl and apply. Let's see cube context. Okay, everything seems to be set up. I will show what we have before applying the command. We have these namespaces, again, increasing the font size. So we have these namespaces. This is a vanilla K3D cluster, so basically there's nothing inside. And let's apply the command that you need. Since that everything is done, you can see that we created a namespace, a service account, a few cluster roles and cluster role bindings, the secret that will be needed by the agent that we just added to this file, and a deployment as well. Of course, you should never ever commit your secret to Git if you add it as a file as we did here, but we take care of that in this repository. In that directory, there's a git ignore, and that changes there will be ignored every time. So let's set the agent version. This is actually the only change that appears within Git, and let's push it just to save everything. At the end of the demo, you can think about how you can turn this agent to manage itself, because we will install some applications into this cluster that are needed, that enables you to manage even the secret within the Git repository. So, but now if you go back to the agent, we see the GitLab agent namespace. We saw that was created, and we see the agent pod as well that's running, and you can check out its logs. There isn't much happening because the configuration file is actually empty. So let's start by adding something to this configuration. I will deploy now the Bitnami sealed secrets into this cluster. Bitnami sealed secrets enables an encrypted storage of secrets within your Git repository. And by using the custom resource definition, the encrypted secret is deployed to your cluster, where the in-cluster component decrypts that secret and creates a normal Kubernetes secret. So the unencrypted version only lives within the cluster action. Installation, actually, I know that I should go to the releases and have to look at the controller YAML that we will add to our project. Kubernetes agents. Yeah, let's just add it there and we'll move it around. So as you can see, this is pure vanilla Kubernetes manifest, and we set up the agents to use this, to grab this manifest and apply it in the cluster. How do you do that? First, I prefer to create a, not there, but at the top level, a directory that holds all the manifests because, oops, this is not a directory, but a file. So I prefer to have a directory that holds all the manifests because in a true setup, you will have multiple of them. And then we have to configure the agent to use this manifest. I opened here the documentation on how you can configure the pool-based approach around the manifest. I will leave many comments in this file for now, but of course, feel free to remove them in your own setup. You will need the project's slug that you use in this case. That's GitLab examples, ops, GitOps demo, Kubernetes agent. You can specify a default namespace. Let's have it default in the, though we always specify namespace in our manifest, so it doesn't matter much. And they will deploy every YAML file under the Kubernetes directory. There are a few other things that you can set as well, like resource time and dry run strategy, many other things that are documented in the comments. We leave everything at the default right now. So we only configured where the YAMLs should come from. And I think we are good. So let's see what happens next. Added sealed secrets. And we will see a very interesting thing because the deployment will fail. It will fail because the agent doesn't have the necessary access rights to apply this YAML that we have here. It doesn't have the rights to create new roles, for example, just to get started with. So we'll have to change that. And all of that is to be shown up in the logs here. You can see the event types, and at the end, actually, we might have had all the, yeah, there are no errors. So it just worked. Okay, then we had enough rights to apply it. The next step is to retrieve the public key used by sealed secrets. And just to make sure that we have everything set up, you can check out namespaces, and sealed secrets is actually deployed under kube system if everything goes well. And you see it here, sealed secrets controller. So the next thing is that we need to get the public key from sealed secret. Sealed secrets has a client-side app that you can run for sealing your secrets and for a few other activities like fetching the certificate, the public certificate of used in for the decryption. We are just going to add that to the repository. As it's a public key, it's not an issue. You can freely commit it to a Git repository. So with this, what we have seen, I will try to give you a quick recap, is we installed the agent. After first we registered it, we got a token. Then we use kpt and customize to install the agent into our cluster. And we installed sealed secret using pool-based deployments. We just committed the manifest files into a Git repository. We didn't need any CI files, nothing along those lines. The agent just grabs those manifest files and applies them in the repository. And now we have sealed secrets ready for action. The next step of the demo is that we will use these sealed secrets to install the runner and together with another GitLab feature. So for that, let's head over. This is done. This is good. You can see that the agent is connected once we did all of this actually. So the next item is to install the runner, as I said. For that, in this same group, I will create another project. But for that project, I will use a template. And the template that I need is the GitLab cluster management project template. Let's call it cluster management. And it can be public because we don't store any secrets in there. What we will use is called the CICD Tunnel, and I will give you a quick idea how it works in a minute. But first, let me introduce you this project. This project is a set of ham files with which you can easily install quite a few applications that integrate with various GitLab features. For example, as you can see, there's Set Manager, there's Set Manager and Ingress in here that you can use together with Auto Deploy to set up a TLS endpoint and an ingress in front of your applications. Or we have Cilium, Aparmore, Falco, and other security-oriented applications within this repository that, again, you can just install in the cluster and integrate, for example, the already mentioned container network security policy alerts together with GitLab. And all of this works using this project and the GitLab Commands agent in an integrated fashion. So what we will use, it will be just runner installation. But first, let's see how can we access that, because as you can see, this project actually comes with a GitLab CI YAML, and that GitLab CI YAML seems to be kind of self-contained. So how can an agent use this one? That's the big question. And for that, I want you to meet the CICD tunnel. I will create a new file in our agent repository here, a GitLab CI YAML file. And in that YAML file, I will just have something very, very simple. Almost this one, but we'll modify it a little bit. Instead of getting the pods, first, I want us to get the available contexts only. And we run this command first. Let's call it a test job because there isn't much happening inside. So if I push this to the repository, we should see GitLab CI to pick it up. And we expect, oh, not in this project, but in the other project. And we expect the pipeline to be run. Let's have a look at what happens. There is an error, kubectl command. Oh, because I mistyped the command in the script. While it runs, I will have some drink because I don't have a tea or coffee. So the idea is that GitLab injects a kube context for every agent that a given project has access to. In this setup, we are within the agent project. And you can see that there is this context available for us. So I could use it, for example, here, and use the namespace as all namespaces. I think this is the right code. And then it should show me all the pods that exist in my cluster. But actually, I'm not interested in this. So in order to move a bit faster, I will just forget about all of it right now. And let's head over to the runner project that we actually, to the cluster management project where we want to install the runner. How can we use this CICD tunnel in this project? That's the big question. So first, let's see what we have. I will add, let's use the web ID here, just because it will be clear when I am in which project. and edit the GitLab CI YAML. I will increase the font size if I can. Here we go. And we'll add the same test job here. I guess I need to add a stage as well. And in the meantime, I will clean up a little bit the CI, because I actually don't need the ham2 release detection. I know that ham2 applications were never installed in this cluster. So let's see, commit directly to master and Brave, CI test job. So I go to the pipelines and nothing was run. Why is that? Okay, then let's just trigger a run. Oh, here we go. It was just not picked up in time. As you can see, there are no contacts available for me. And the reason is just security. You don't want all your agents to be accessible by all the teams. You have to enable a specific agent to be accessible by other groups or projects. So for this, we have it documented under authorizing the groups to use the agent. So I will have to add something like this to my agent configuration. Here we go. Here we go. And you add the new section where I authorize the group GitLab examples of GitOps demo to have access to this agent. Okay. To access CI tunnel. And we do a git push again. Followingly, if I would rerun these pipelines where, oh, not this one, this is the agent repository, but this one where we don't have a context available, the context should actually appear. So let's do that. And using this context, we will be able to run the GitLab CI YAML in this cluster management project. Let's see the test job. The other job is still expected to fail, and you can see now we have the agent available there. That's amazing. So I have a small snippet that I'm going to use here that will need to be changed to use the kube context that we want, and then extend this script with this use context. So what we do, we change the default template that comes with the CICD, with this management project, and we change the apply step to use this kube context. We set the context using the example here. Okay, let's commit the change to master, use the agent context. And now our apply already should work, but there are still a few issues with that. Namely, if you look at the files there, we still have nothing configured. No application is enabled. This ham files based application works in a way that there are a set of ham files, one for each application, and you have to configure that ham file and the application. So one thing you can do here is to go back to the web IDE, open ham files, just enable runner. And then you likely want to check out the possible settings for the runner in this values YAML Go template file. That was changed recently to have a Go template, so I don't know this format that well. And you can add your runner registration token here. Oh, I just realized that we don't need to use seed secrets this time. And as we are running out of time, I might just shortcut the approach here. So what we can do is that I create a setting, go to CICD, and set up that variable to use to register the runners. Under runners, you can find the registration token. That will be the value here. It is to be masked. And once we have all these things, you can commit these changes. And let's see for the pipeline to pass. What I wanted to show, but as we are short on time, I won't go into detail there, is that you could use seed secrets as well to store the secrets inside of your agent repository that is here, and have that secret pulled into the cluster, and that will be your runner token secret, and specify in your values YAML file that we use that secret. If I would like to finish the talk at in like 3 minutes, but if we get there, I will try to show it as well. But let's see what happens here. Apply failed. No context exists with this name. Okay, then let's check our context, because I might have mistyped something there. And move it. Keep context. It did not change. Okay, now we have to debug this issue because I would expect it to work. Okay, let's list the context as well here, just to be sure that we don't miss anything, and then I will just remove this test job. Where is my running job? Here we go. This is very interesting. We see one context there that comes from the legacy integration. And we saw the other context as well. If we run the test job, the truth is I'm a bit puzzled now what might be the issue, because it was shown in one case, but not in the other, the context that we are looking after. What might be the reason for that?
Victor, this is Mikhail. I think
Yes.
the difference is that your apply job has the environment specified and the test job didn't have an environment.
Correct. And this environment is actually given. Okay, let's explain everyone what's happening. Under infrastructure Kubernetes clusters, you can see two tabs. One is the clusters connected with certificate and the agent managed connections. The agent managed connection comes from a different project, but here, this cluster has an environment scope of star that is all the environments. So the issue is likely that whenever we specify environment here, that will pick it up. Let's just remove it and see if it works now. This doesn't mean that you cannot reuse the environment syntax in your CI if you use the agent. It just means that if you have the legacy integration with the cluster certificates set up, then you might get into trouble. So the two might be, you might not be able to use the agent in this fashion. Okay, and now our apply job runs. And hopefully some more data will come in. Yeah, now we can see the context is available. So this whole scripts that we saw before that comes from the template itself is being run. It takes quite some time because it assures that namespaces are there. It checks if GitLab owns these deployments, whether deployments are there already, and has to apply all those changes. And once the pipeline is over, we should see our custom runners, register runners just for this project under the CICD settings within GitLab. It should show that there are some custom runners available for us. It takes a long time, longer than I would have expected. A few more words about the agent until we wait for the pipeline to finish. As you can see, the agent lives within your cluster. As a result, it's managed by regular Kubernetes Airbag, and it will be only able to act on resources that it's allowed to act on. So we don't require you to provide us cluster admin rights or anything along those lines. You can restrict the agent as much as you want. We try to make it very lightweight. As a result, even multiple agents might be able to run in a single cluster. And we see here an error that we are actually aware of. Sometimes this CI tunnel breaks down if it's under heavy use. We are currently working to fix this. So I will just hit a retry and we'll start to speak, continue to speak. So as we live within the cluster, this approach works even with OpenShift clusters or other more secured clusters as well. everything is just how you configure the agent inside the agent K component that we installed inside the cluster itself. You can use it with a few other integrations that GitLab provides. Basically, all the apps in this cluster management project provide various levels of integration inside of GitLab, like they already mentioned, container network security policies, for example. They just surface the alerts into GitLab if there is a breach. Let us know if there are any more questions in the chat, and I'm more than happy to answer them as long as we wait, as there are only a few more minutes left from this call. If not, I will switch back a bit here, and I will check the pipeline from time to time. We have a short poll for you as well to ask you about which part of GitOps or infrastructure management would you be interested at. If we can see the poll, please.
I'm starting the poll, but there are 2 questions in the F&A section. You can check out meanwhile.
Where is that section?
At the bottom where it says F&A, I can read the question. The first one is, how can I build a GitOps strategy to deploy Google Compute Engine instead a K8s cluster with Terraform? Are there an integration with GZE instead with GKE?
Okay, so I see that this question falls definitely under the infrastructure provisioning section. We recommend everybody to use Terraform or other infrastructure provisioning to set up your clusters. And today in the docs, we ship an example project only for GKE and not for other clouds. But you can use Terraform for any of those, and the integrations that GitLab provides should just work. So we don't have specific integrations for GKE. We don't have specific integrations for EKS or any other cloud provider. We have integration with Terraform to be provider agnostic. As a result, as long as they have Terraform modules that, and you can set up the cluster with Terraform, you can use the same set of integrations that we provide. Let it be the GitLab managed Terraform state or Terraform module registry or the merge request widget. The pipeline is still running.
That's another question.
Yes.
In how far is the agent similar to Argo CD for using GitOps?
Yeah, that's a very good question. Actually, we started with some shared code base that was called the GitOps engine. That's the underlying GitOps code base for Argo CD, but we moved away from it for good reason. We just found that it has a few unnecessary dependencies, and we could make the agent more lightweight and more modern in terms of how it operates within the cluster, using something that you might have spotted, the inventory policy object that we speak about in the docs and in the agent configuration. So it has some common roots, but actually moved away from the shared code base. In terms of functionality, from the user's point of view, it serves the same needs. The idea is that you want pool-based deployments, and both give you pool-based deployments. Argo CD, just to mention a third tool in this space, Flux, compared to Flux, is, I would say, provides a better user experience. It's a bit easier to use than Flux, and it has an amazing UI. With the agent, we don't have the same level of UI yet that Argo CD has, but it provides us a huge amount of inspiration, and we would like to be the better UI than Argo actually has. And having it integrated with GitLab actually enables us features that Argo just cannot provide. Like what you saw here with the CICD Tunnel, where you can use GitLab CI for push-based deployments. Argo is only for pull-based. So you always have to somehow make your repositories available to the Argo instance. Here it's more developer-friendly with having push-based setup, because developers might be familiar with those workflows, while they might not be familiar with the pull-based approach, and the change of mind might be harder to get. Similarly, with the container network security integration, that's simply something that Argo likely will never have. With GitLab, you can configure container network security policies within GitLab You can even deploy them with a pool-based fashion using the agent. And if there's a breach, it will be surfaced into GitLab as an incident. And we are just adding container network security scanning as well. So these are the things. Argo is great for pool-based deployments. It actually has a little bit wider support in terms of the tools that it has, like it supports Helm and YAML, JSON.NET and whatnot. We only support pure vanilla Kubernetes manifests, but we think that this is a better approach actually on the longer term for our users, because you can always hydrate from your templating tool into Kubernetes manifests most of the time, not always. And that's a better approach. And with all the other integrations within GitLab, we add a little bit more value than Argo can provide. Any other questions that came in?
No other questions at the minute. I just wanted to, so do you want to go back or?
Yeah, one more note about this QR code. We just started to release a series of blog posts around GitOps with GitLab. I think the first one came out on Friday, and this QR code leads to the first article in that series of blog posts. So if you want to read more, there is infrastructure provisioning discussed as well with GitLab, and monitoring will be as well. Okay, we got the same error. Sorry for that. The CICD tunnel, in a sense, should work this way. You can see that it basically runs the kubectl commands or any other command that uses kube context in the CI and reaches out to GitLab. So that was the demo for today, and thank you very much for your attention.
There's another question coming in. How do you see this working with Azure Arc for hybrid cloud?
It should just work. So the nice thing is that as long as you use Kubernetes, you can install Agent K in the cluster, it will work. As you can see in my demo, it's not a hybrid cloud in the sense that it's a local cluster, but actually I'm using GitLab.com at the same time. So you just need an egress and not an ingress to basically from your cluster, you have to be able to access the cast.gitlab.com domain in our case. And as long as that's possible, it should work without any issues. Of course, on self-managed GitLab instances, it means that the agent K should be able to access your casts besides your self-managed GitLab instance.
Okay, thank you for answering this. Yeah, well, also thank you from my side. Quick reminder, you will receive a follow-up email with recording and slides and some further information. So you can also watch the first 2 demo days in case you might have missed them. And I have put a link in the chat for you. So in case you're interested in an interactive security workshop, you can check out our security workshop, which takes place tomorrow. So just click the link in the chat and have a look. And yeah, thank you very much for attending. It was a pleasure to have you with us, and see you next time. Thanks. Bye.